Every day, millions of people type a question into a chat box and get an answer that sounds remarkably human. But behind that friendly reply is no person at all, just math, patterns, and an enormous amount of text. So how does a program like ChatGPT actually pull this off? At its core, ChatGPT is a type of artificial intelligence called a large language model. That means its entire job is to predict what word should come next in a sentence. It does this over and over, one word at a time, until it has built a full response. To understand this, imagine a friend who has read almost every book, article, and website ever written. Now imagine that friend playing a very sophisticated guessing game. Given the start of a sentence, what word is most likely to come next? That guessing game, done at a massive scale, is the foundation of how ChatGPT works. Before ChatGPT can guess anything, it has to break language down into smaller pieces called tokens. A token might be a whole word, or just a few letters, like the pieces of a puzzle. The model doesn't see sentences the way we do, it sees long strings of these numbered puzzle pieces. Each token gets converted into a list of numbers called a vector, which captures something about its meaning and how it relates to other words. Words with similar meanings end up with similar numbers, so king and queen sit closer together than king and banana. This numerical map is how the model handles meaning mathematically. The architecture that made modern chatbots possible is called a transformer, introduced by researchers in 2017. Its key trick is something called attention, which lets the model weigh how much every word in a sentence matters to every other word. This is how it figures out that in the trophy didn't fit in the suitcase because it was too big. The word it refers to the suitcase, not the trophy. Picture a classroom where every student is discussing a sentence together, and each one raises their hand with a note about how much attention to pay to every other word. That collective back and forth, repeated across many layers, is roughly what attention does inside the model. The result is a system that can track context across long, complicated sentences. To get good at predicting words, ChatGPT first goes through a phase called pretraining. During this stage, it reads through a staggering amount of text scraped from books, websites, and articles, adjusting its internal settings billions of times to get better at its guessing game. This process alone can take months and enormous amounts of computing power. Inside the model are billions of adjustable numbers called parameters, like tiny dials that control how strongly one idea connects to another. Training is the process of turning those dials, very slightly, every time the model makes a wrong guess. Repeat that correction billions of times, and gradually a system emerges that produces surprisingly coherent language. But reading the internet doesn't automatically make a model helpful or safe to talk to. That's where a second stage comes in, called fine-tuning. Human trainers review the model's responses and guide it toward being clearer, more polite, and more useful. One powerful technique used here is called reinforcement learning from human feedback, or RLHF. Human reviewers rank different possible answers from best to worst, and the model is nudged to produce more of the highly ranked kind. Over time, this shapes its personality, making it feel more like a helpful assistant than a random text generator. So when you type a question into ChatGPT, what actually happens? Your words are chopped into tokens, converted into numbers, and fed through the trained network. The model then predicts the most likely next token, adds it to the growing response, and repeats this process again and again until it produces a full answer. This word-by-word prediction happens astonishingly fast, but it also means the model isn't planning out a whole essay in advance the way a human writer might. It's closer to composing a sentence one careful guess at a time, each guess informed by everything written so far. In a sense, ChatGPT is always finishing a very, very long sentence. It's important to be clear about what this process is not. ChatGPT does not look things up in a live database, and it does not know facts the way a search engine retrieves them. Instead, it generates text based on patterns it absorbed during training, which is a very different kind of process from human understanding or fact-checking. This is also why ChatGPT can sometimes produce confident-sounding statements that are simply wrong, a phenomenon researchers call hallucination. Because the model is optimized to generate plausible-sounding language, it can occasionally invent a fact, a citation, or a quote that never existed. Scientists are still working on ways to reduce this problem. Another key limitation is the context window, which is essentially the model's short-term memory.
ChatGPT can only see a limited amount of the conversation at once, measured in tokens.
Once a conversation grows too long, earlier details can fall outside that window and get forgotten.
It's tempting to think a system that talks this fluently must be thinking or feeling the way we do, but current evidence suggests otherwise.
ChatGPT has no goals, no memories between separate conversations by default, and no awareness of itself or the world beyond the patterns in its training data. It's a highly skilled pattern matcher, not a conscious mind.
Still, the results can feel uncannily intelligent because language itself encodes so much human knowledge and reasoning.
By learning to predict text extremely well, the model indirectly absorbs patterns of logic, grammar, and even step-by-step problem solving. This is sometimes called an emergent capability, a skill that appears simply from scaling up the training process. Researchers have found that as these models get bigger, trained on more data with more computing power, they sometimes gain abilities that weren't explicitly programmed in. Simple arithmetic, basic coding, and multi-step reasoning have all appeared this way in larger models. Scientists are still studying why scale produces these jumps so reliably.
This scaling has a real-world cost, though.
Training a large language model requires thousands of specialized computer chips running for weeks or months, consuming significant amounts of electricity. That's one reason only a handful of large organizations can currently build models of this size from scratch. Once trained, though, running the model to answer a single question, called inference, is far cheaper and faster.
That's why you can get a reply in seconds rather than waiting for another months-long training run.
Every message you send is handled by the already trained, frozen version of the model. Because of these strengths and limits, ChatGPT tends to shine at tasks like drafting emails, summarizing text, brainstorming ideas, or explaining concepts in simple terms. It tends to struggle with tasks that require up-to-the-minute facts, precise arithmetic on large numbers, or guaranteed accuracy on niche technical details.
Knowing this difference is the key to using it well.
Newer versions of these systems are being connected to outside tools, like calculators, search engines, and code runners, to patch some of these gaps. This means the chatbot of tomorrow may increasingly blend its language prediction skills with the ability to check real facts in real time. Researchers describe this as one of the most active frontiers in current AI development.
So the next time a chatbot answers your question in a perfectly friendly, fluent paragraph, remember what's really happening underneath.
It's not a mind thinking about your problem, it's a vast statistical pattern, trained on human language, quietly predicting one word after another. Understanding that difference is the first step to using these tools wisely, not with blind trust, and not with dismissive fear.